Welcome to my channel Phi Concepts CHM. In this video, we are going to see about FET characteristics experiment, where we will see about the aim, apparatus, circuit diagram, procedure, observation table, graph, calculation, result. Aim: to study FET characteristics. Apparatus: required FET circuit, milliammeter, voltmeter, power supplies. This is the circuit diagram with two supply voltages. This is VGG and this is VDD. Then there is a rheostat to vary the VGS voltage. This is the gate resistor. This is the FET. Here there is a drain resistor. Here again there is a rheostat to vary this VDD voltage. VDS is measured in this voltmeter and VGS is measured in this voltmeter. And this milliammeter is to measure the drain current. Procedure. First part is the drain characteristics. Connect the circuit for drain curves. Keeping VGS is equal to 0 volts, vary VDS from 0 volts to 10 volts in suitable steps and observe the corresponding values of drain current ID. Repeat the above procedure, keeping VGS is equal to minus 0.5 volt, minus 1 volt and minus 1.5 volt. So this way we take the readings. We keep VGS is equal to 0 volt and vary VDS by 0.5 and note down the current till it becomes constant. Here the current has become constant at 10 milliamperes. Again we change VGS to minus 0.5 volt. Repeat the same thing. We change the VDS and note down the drain current. Again the drain current becomes constant at 8 milliamperes. So this way we take the readings again from VGS is equal to minus 1 volt and VGS is equal to minus 1.5 volt. Then we plot a graph of ID versus VDS. We show the ohmic region and the active region of the characteristic curves. Determine the pinch off voltage VP from the graph, that is for VGS is equal to 0 volt curve. Obtain the values of RDS of the JFET operating in the ohmic region. Tabulate the value of RDS against VGS. So we get this graph of ID versus VDS, and these different curves for VGS is equal to 0 volt is a topmost curve, then minus 0.5 volt and so on. Then find the slope in the ohmic region so that we get this RDS. RDS is 1 upon slope. We get the value of RDS for different VGS. Second part is to find the transconductance curve. Connect the circuit. Keep VDS is equal to 10 volt. Observe IDSs when VGS is 0 volt. Vary VGS from 0 volt downwards through the negative value till the drain current ID tends to 0. So we get this readings. We have kept VDS is equal to 10 volt. This is VGS. We are increasing and noting down the corresponding drain current till it becomes 0. Then we plot ID versus VGS graph. We will note VGS off from the graph. Calculate GMO, that is the transconductance, at VGS is equal to 0 volt from the graph. Also, we will calculate VGS off from the formula. ID is equal to IDSS into 1 minus VGS upon VGS off the whole square. Compare the value of VP obtained from the drain characteristics and from calculations. So this is the graph of ID versus VGS. Here we get VGS off, and this is the maximum current IDSS. We find the slope at IDSS, that is denoted as GMO, the transconductance, when VGS is equal to 0 volt. So this is GMO. This is the calculations where we find VGS off, which is actually equivalent to the pinch off voltage. This is the result. This first part we get from the drain curve. For each curve we have found RDSS. GMO we get from the transconductance curve. VGS off also we get from this curve, and VGS off from the calculations. Thank you for watching this video.